Hello. So in this screencast I'm going to build a stream of citibike arrival events using Python and push them into a browser using a WebSocket. I'm going to be using a bash shell on OS X and Python version 2.7. I'm going to use the request module in Python to poll the citibike API. So, as in the previous screencast, I will start by exploring the citibike data using curl piped to JQ before writing any code. To recap, I'm going to use curl to make HTTP requests. I'm going to use JQ to pass the JSON from citibike. I'm going to use head, which is a program that we use to look at the top few lines of a piece of text, in our case in a HTTP response. And I'm going to use WebSocket D to create a simple WebSocket server for us from the command line. In the browser, I'm going to be using the D3 library, which is a JavaScript library for manipulating web pages based on a dataset. And I'll just do some minimal JavaScript. And I'm going to be working a lot in the browser's console. I'm going to serve a web page containing the D3 library using Python's simple HTTP server. Okay, so first let's curl the citibike API to have a look at what it looks like. So this is the citibike API URL. Oops. I misspelled citibike. Let's try again. Okay, so as you can see, there's quite a lot to this response. So let's start at the top. We can pass this response using JQ to pretty print the JSON. But as you can see, if I scroll up, this is still far too long to get a handle on. So let's just have a look at the top of the response. So to do that, we pipe the response of JQ into head. And this shows us the top 10 lines of the JSON. So we can see that there are two keys at the top of this JSON, the juicy one being station bean list. Let's use JQ to find out how long this array is. So I'm going to use JQ's notation to access the array. It's called station bean list. And then I'm going to, within the JQ string, use a little pipe and pass it to the JQ function length. So how many have we got? So right now we've got 506 stations in the response. Notice that JQ accepts a string argument and that it uses the idea of pipes internally. So here we ask JQ to calculate the length of the station bean list array. We're going to want to know the fields of some of these stations, so let's have a look at the very first one, which you can do using this command. Here's the very first station in the list. It's on West 52nd Street at 11th Avenue. So we're going to, for later, we're going to need to remember the available bikes field and the station name field. Okay, so we're going to need this one and this one. So let's do the same thing, but let's write it in Python so that we can start to do some more advanced work. So I'm going to use the Vim editor to write some Python. Occasionally I'm going to call out to the shell from within Vim, but I'll let you know when I do that so that it's not jarring. So first I'm going to import the requests module, which we use in Python to make HTTP requests with, which is great. So let's use that to make a simple GET request to the citibike API. Okay, and so R is our request body. We can have a look at the parsed JSON by simply calling r.json. So I'm going to run this script from within Vim. All I'm doing here is calling out to the shell using Vim's ban command. And so I'm going to run Python in the shell, and I'm going to use the %sign, which is another Vim thing to refer to the file being edited. So all this is going to hopefully do, oh no, got to save it. So all this is going to hopefully do is print out the same piece of JSON that we saw before, except now this is represented as a Python dictionary, which is great. So let's write a bit more code to keep track of how many available bikes there are at each station. We're going to do this by building up a dictionary that stores the station name as the key and the number of available bikes as a value. So let's call this citibike. So for station in, oops. So we're going to go through every station and we're going to extract the station name, which is station name, I believe, and the number of available bikes. I can't quite remember if I've got those keys correct, so let's just run this briefly to see what we get. Yep, so hopefully you can see the station name on the left and the number of available bikes on the right. So I'm going to go ahead and put this in a dictionary. Let's call this bikes. So I'm going to say bikes station name equals available bikes. Okay, so now if I print bikes, hopefully we should get a dictionary where the station name is the key and the number of available bikes is the value. Okay, so now I'm going to do this every 5 seconds. So let's say while true, Python, we'll do this, and once we've finished going through this and updating our bikes dictionary, we'll sleep for 5 seconds. I need to remember to import time. Okay, so now if we run this, we should get a dictionary every 5 seconds. There we go. Okay, so pressing Control-C to exit out of this loop. So now what I'd like to do is compare the most recent value that I get from the citibike API with the previously stored value to see if there's been any change. So let's first of all check to see if the station name is in the bikes dictionary. Actually, let's check to see if it's not in the bikes dictionary. And then if it's not, then what we'll do is enter it and then continue the loop. Oops. Otherwise, we can extract the number of available bikes. So let's do this, bikes station name. And let's subtract that, which is the number of available bikes 5 seconds ago, from the number of available bikes we just got from the API. I'll call that delta. I'll call it bike delta. So this is the number of, so this is bike station name was the number of bikes that were there. This is the number of bikes that are available now. So if we want to keep track of bike arrivals, then we want to see if bike delta is, so an arrival is a larger number now. So this number will be smaller than available bikes. So bike delta will be greater than 0. And let's just print a little message. Bike arrived at, and then station name. Okay, and then let's update our dictionary with the new number. Okay, we don't want this statement anymore. So let's just recap. We go through each station in the bean list. We get the station name, we get the number of available bikes. If we haven't seen this station before, we simply add it to the dictionary and move on. Otherwise, if we have seen this, then we're going to take the number of bikes that were in the station 5 seconds ago and subtract from that the number of current available bikes. And then we say if bike delta is greater than 0, so if the number of bikes used to be bigger, look, I've done this the wrong way around. So let's replace this with less than 0. So if the number of bikes was bigger than the number of available bikes now, then we've lost bikes, and what we want to do is keep track of arriving bikes. So if the bike delta is less than 0, we know that the number of available bikes is bigger than the number of bikes that were, and so we know some bikes have arrived at the station. In fact, let's say bike delta bikes, so we know how many have showed up. And then we update our dictionary ready for the next step of the loop, and we sleep for 5 seconds. For demo purposes, let's move this to 2 seconds. And just to make sure everything is running, I'm going to also print a little message to say that I'm checking. Then know everything's working. So let's run this and see what kind of errors I've missed. Great. Okay, so here it is, checking every 2 seconds to see if any new bikes have shown up anywhere in New York City. So one of the joys of demonstrating streaming systems is that there's no real reason anyone should be using bikes at this very moment. but we'd expect some traffic. It's not too late. Okay, so I'm quite impatient whilst demonstrating, so let's do one more thing. So I've pressed Ctrl+C to break out of this loop. So let's add another print statement in case people are taking bikes out. So if the bike delta is greater, then that means we've had some bikes departed from. So let's run this again and see if we see any more bikes departed from than we do bikes showing up. It is 9:45 at night on a relatively cold evening, so we don't expect too much traffic. We hope it's non-zero. So either no one's using citibike right now, or there is a bug in my code. So let's wait for a few more seconds and then go and have a look at the code. Okay. So let's print out some things so that we're not worried we're messing things up. So let's print out the initialization. Okay, so I'm running it again. Okay, so we can see all of the, it's initializing every time. So we're doing something wrong. If station name not in bikes. Yes, of course. Bikes need to be outside of the while loop, otherwise I just wipe it out every time. So let's try again. So here I go, I've initialized the bikes dictionary now outside of the while loop, where I should have. And let's see. Okay, there's the initialization. And there's the checking. An error. So unsupported operand. Oh, okay, great. So we've got a bike delta, which is exciting, but we forgot to turn it into a string. Let's do that. Okay, let's see if there's any other errors. Initialization, checking. Oh, hooray! So we had -1 bikes arrived at Howard Street and Centre Street, 1 bike depart from Washington Ave and Park Ave, and 1 bike depart from East 11th Street and First Avenue. So again, 3 all at once. That's a bit curious. Let's see if we get 3 again. Oh no, look. So lots of action. So you'll notice that there's a pretty similar number of checks between each update. So that might suggest something about how the citibike system works in little batches. Yep. So every, how many? 1, 2, 3, 4, 5, 6. So every 12 seconds or so, it updates. So that would be an interesting thing to really go and figure out. But it does suggest that our sampling of every 2 seconds is a bit fast. So let's turn this into a stream of data that we can actually use. So instead of printing a string, what I'd like to do is make some JSON. So I know that I would like to take, actually let's just make a JSON of the bike delta. So bike delta is going to be this. Actually, let's use a format string. And we want station name. And that should be okay. So we do bike delta station name. Okay. And because we know that a minus sign is a bike arrived and a plus sign is a bike departed, I'm going to multiply bike delta by -1 to change that sign, because I find that quite complicated. An arrival should be a +1 and a depart should be a -1. So let's see if this works. For now, I'm going to comment this out. So let's see what this looks like. We should put quotes around the string. And I'm going to get rid of the checking string, because this would like to be a nice, neat stream. So there's the initialization, and then we forgot to ignore 0 bike deltas. So I pressed Control C. So let's say if bike delta is not equal to 0, then print. And let's get rid of this. Okay, so now we should have a nice clean stream. Here we go. So the bike delta is -1 at Great Jones Street, 1 at 11th Avenue and West 41st Street. Okay, so here's my stream of data. I can get it by polling the citibike API. So now the last thing I'd like to do is get this into a WebSocket. So I'm going to cancel this. I'm going to make sure that I've saved my work and then quit. So now I can run this example and get my stream of data. Okay. So one last thing that I forgot to do, which I also forgot to do in class, is to flush standard out immediately after I've printed the line. So I'm going to call sys.standardout. I think it's .flush. See if that works. What this does is it stops Python from creating a buffer when we connect this up to other programs. Okay, great. So now I can, for example, now I can push my example through JQ to get it pretty printed. There we go. Or I can use WebSocket D to wrap this up in a WebSocket. So let's use port 8080. We should be able to connect to this from a WebSocket. So I'm going to go and get a Chrome browser screen. Going to briefly visit the About blank page, which is a nice pre-built web page that we can use, and then I'm going to try and connect up to this WebSocket. So I'm going to say the variable ws is equal to a new WebSocket at this location and port 8080. Okay, so you can see our WebSocket server saw the connection, and then I'm going to define an on message. So what this is going to do is take the message that shows up through the WebSocket, passes its data field, and then logs it to the console. So this is the super simple thing that we can do just to make sure that we're getting some data. So with any luck, within 5 or 10 seconds, we should start to see some citibike data. There we go. It's a relief. So this should look pretty familiar. We have some a bike delta and a station name. So the last thing that I'd like to do is actually write this to a web page. And to do that, I need to serve up a web page containing D3. So here we are in the GitHub folder for the course. I'm going to have a quick look at index.html. So hopefully you can see that we're importing the script, the D3 script, and there's a little bit of JavaScript and an unnumbered list. So this is the beginnings of a bullet pointed list. So from within here, I'm going to serve up the Python simple HTTP server, and I'm going to do it on port 8888. So let's go and visit there, localhost 8888. Okay, so now we can see we have access to D3 in the console, which is great. I'm going to make my WebSocket again. So here we go, connect to localhost 8080, which is where my WebSocket is. And now instead of logging the data, what I'm going to do is a little bit more. So I'm going to say data equals json.parse message data, and then I'm going to select the unnumbered list, D3, and I'm going to append a list item, and its text is going to be data dot, what should we do first? Let's just do the station name to see if we've got it right. Okay, I think that looks correct. Let's give it a go. So hopefully if some data shows up, we should start to see. Let's put a console log in just so that we don't go crazy wondering if there's any data. Here we go, console.log data. So now we sit here and wait for someone to use citibike. There we go. So something, we can see all these little bullet points have shown up, but we haven't quite got the, we've misspelled station name. Okay, so let's overwrite our onMessage function with a correct one, spelling station name correctly, and then hopefully we should see some new, here we go. Great, so here's our unnumbered list with some actual text in them. And there we have it. So what we've done is go through kind of quite quickly an example where we consume a stream of data by polling a stateful live endpoint. We've turned that into events by essentially building a difference. And then when we find differences that are not equal to 0, we emit them using our Python script. And then I've used websocket to wrap that Python script up in a WebSocket and then consumed it from within the website. And all I've done is very, very simple append to a list of the stations that are receiving or losing bikes. Okay, thanks very much.